Good morning, students. As a continuation of previous class, so our fuel cells. So we already know that fuel cells are the devices which converts the chemical energy from a fuel to electricity. So we know that function mechanism and so on. So now we are going to next type of fuel cell, that is the PEM fuel cells. So PEM fuel cells is nothing but the proton exchange membrane. Proton exchange membrane fuel cells. So it is also called as polymer electrolyte. Polymer electrolyte fuel cells. The name itself, it is showing that usage of polymer electrolyte membranes. So as in the case of hydrogen oxygen fuel cells, now we are going to use as a membrane of polymer materials. So these are the main differentiation between the hydrogen oxygen and polymer electrolyte membrane fuel cells. So by the usage itself, it is going to use for mostly transport applications, as in the case of either stationary or portable fuel cells. So this is the main advantage of PEM fuel cells. So we know that construction of hydrogen and oxygen fuel cells. So again we may recall that one. So this is the anode compartment and this is the cathode compartment. In between that, what we are telling that electrolyte. So here is some polymer electrolytes. So this consists of polymer electrolyte membrane. So this is main differentiation between that hydrogen oxygen fuel cells. Remainder things are the same, as it is connected as external load and it is anode and cathode. So we may know that the input and output. So here is the hydrogen is coming to inside and here it's oxygen is coming to inside. So here the H plus ions are creating and electrons are creating. So this is the simple construction of polymer electrolyte membrane fuel cells. Then we have to know about that electrode materials and electrolyte, that means of membranes. So here we may use as the electrode, special type of PT based materials, that means platinum based materials are used as the anode and cathode. In this PT is having that potential to split that hydrogen gas, say, into hydrogen ions. So term itself containing the proton exchange membranes. So these proton ions will undergoes in that membrane, then act with anode compartment. So it has to move in the membrane surface. So we have to select upon that electrolyte or membrane. So in the case itself, polymer electrolytes. Generally, Nafion is a membrane which is used in the polymer electrolyte fuel cells. So in this kind of fuel cells, so that means Nafion membrane relies on water humidifications. So depending upon that one, this H plus ions moves inside the layers of Nafion membrane, and that usage of this Nafion membrane is up to 80 to 90 degrees Celsius, because beyond the temperature itself this Nafion membrane gets dried. So it is the main difficulty to use these membranes, And in the case of by replacing recently some other polymer membranes are coming in the category of this fuel cells. So that is nothing but polybenzimidazole, PBI, or phosphoric acids. So we may go for like this membranes. So by using this kind of membranes, we can go up to 220 degrees Celsius as the operating temperature. So our main important of the usaging temperature is also carrying in this fuel cells. So and and finally by the application, sorry, by the identification of that electrode materials, the usage of pt is somewhat restricted due to the cost. So nowadays we are going for pt cerium oxide, pt in cerium oxide, like that some spontaneous materials are in coming across for the PEM fuel cell application. And that main thing of that membrane electrode assembly, membrane electrode assembly, that is mean by MEA, membrane electrode assembly. So it is nothing but how we are going to that making a electrode with a membrane for the fuel cell application. It is also a construction procedure for the making of PEM fuel cells. So typically, a MEA is composed of polymer electrolyte membrane and two anode materials. That means two catalyst layers. One is the anode and one is the cathode. So, if we are considering as a membrane, if you are thinking as this a membrane, so one kind of that catalyst is coated in this side, and another one catalyst is coated in the back side. That means catalyst 1 and catalyst 2. So anodic or cathodic, either anodic or cathodic. So if we are considering this, then one more layer of gas diffusion layer is connected to this. So gas diffusion layer in both sides. So without the gas diffusion layer is the MEA3 type. So three phases, two active electrocatalyst and one membrane, that is the MEA3, with the addition of gas diffusion layer, that is MEA5, because addition of two gas diffusion layers on that one. And if you are making one more sealing on that one in both sides, this is MEA7. So here 7 layers are there. So this numbering are nothing but that layers. How many layers are there? So the 7th layer is the sealing layer, using of some sealing materials. So to protect that environment of MEA, by the usage of this MEA, we may find out where that diffusion is happening. So here this gas diffusion layer is the important thing. So this layer comes in the category of general fuel cells. That means if it is the electrode and it is the portion of electrolyte. So while we are zooming that one, so layers of ions are forming here and metal catalyst are here. So in between the surface, this is the surface layer, here is the gas diffusion is possible depending upon the diffusion. So this movement of ions, that means H plus ions as and that electrons from the solution and going to the anode to outside. So depending upon that porosity, this gas diffusion is possible. and this is more. So by using this MEA, we may get a peculiar type of membrane fuel cell, and sometimes it is called also as a catalyst coated fuel cell, catalyst coated membrane. So CCM. So it is the main heart of the fuel cell. As like our hydrogen oxygen fuel cell, the general reactions are the same. So as in the anodic form and the cathodic form. So in anodic itself, hydrogen is converted to 2H plus and 2 electrons. These electrons going to the, so we may know that one, these electrons are going to the external circuit to the anode surface, and the protons are going, in the meantime protons are going to permeable membrane. So protons are permeability, it goes to the outside of that another electrode. So in cathodic itself, there is simultaneous reduction is happening. So of O2 gives of O2 plus 2H plus and 2 electron minus. These 2 electrons are coming from that anodic side. So we are getting that reduction happening, and we are getting the final product of water plus energy. So and overall net reaction. So we know that we have to eliminate these 2H plus and 2H plus, 2 electrons and 2 electron. So remaining part is H2 plus of O2 gives H2O plus energy. So this is the net reaction of this system, and the main advantages of this system is the polymer electrolyte membrane is lightweight, and for this property it may go for transport application, and it may uses for electric buses. We may get the efficiency of above 40%, and that some of the drawbacks is it has a large volume. Then if you are going to use in a car, that volume of the car is very small compared to bus, so it may used for electric buses application compared to car. So then we may get a more efficiency due to volume of that buses, and it may used for as replacing the batteries for portable electronics, and it may use for automobile application. So even though it has the low operation temperature of 80 to 90 degrees Celsius, and it has rapid startup time including frozen conditions. So if you are going to use in that hill station and some other ice oriented conditions, so we may get easy startup for making it automobiles. Then we may get around 40 to 60% efficiency of this fuel cells. Some of the limitations are the water management. So that the elimination of water is some of the main problem. So while we are using the buses itself, we have to store that elimination of water. So for that we have to give some more consideration. So elimination of water is also a main problem here itself, and membranes are attracted to that polarization of that catalyst. So due to the cathode polarization, some of that active catalyst comes to cathode compartment and attracted together. So it will give that more catalytic poison nature. So continuous usage of this catalyst is somewhat difficult. So these are the main disadvantages of this polymer electrolyte membrane fuel cell. But compared to the hydrogen oxygen fuel cell, it is very useful in the automobile application and transportation. So we may give more consideration for the portable electronics by using this PEM fuel cells. Thank you.